Hello everyone. In this example, we have a case of applying one-dimension kinematic equations when we have two objects in motion. So in this case, or in previous cases when we had just one object in motion, the best thing to do is start by drawing a sketch of the situation. We pick the coordinate axis. Okay, let's say I have my x-axis, this direction, this is my y-axis, or I could say this is my x equals 0 location. According to the problem, we have two objects, the bingo, the dog, and the boy, the Manu. It says the doggy's information and also the Manu's information. It says Manu is 30 meters away, starts walking home backward. Okay, I could say x equals 30 meters. That is the initial position of the Manu, the boy, and he starts walking. Here, right here, I have the other object, the bingo, and initial position x equals 0. Okay, so we are going to put down other informations. It says the boy, Manu, is walking at a steady rate, which is velocity constant 2 meters per second in this direction. V initial equals 2 meters per second, but everyone, positive x direction is along this way. This boy is walking backward. We should have a negative sign because this velocity vector is in the negative direction. And for that boy, acceleration is 0 meters per square second, since this guy is moving with a constant speed. Now getting back to the dog, starting from rest, V initial for the, you could say for the Manu, and for the Manu, this is for the bingo, equals 0 meters per second, starting with rest. And with a rate, right here, the unit says it is an acceleration. Acceleration, it is in the positive direction, positive x direction. For the bingo, that is equal to 1 meters per square second. When they are moving towards each other, we could say somewhere here, they are going to meet each other. This guy is going to move forward, move backwards. Somewhere here, they are going to meet each other. Let's say that is x final. X final position, this guy, X final position for the bingo, the dog, is going to be the same as, because they are in the same location right here, X final position for the Manu. This will be the necessity or the necessary condition to solve this problem. When we have all these ideas listed down, we have these formula, set of formulas. All we are going to do now, set the formulas, substitute numbers, look for the unknown. We are going to find how much time it takes for the two objects to meet each other. When we have it, we have the idea, final position is going to be the same. Let's go with that. I could say this formula right here. X final equals x initial plus initial velocity time plus 1/2 acceleration time squared. That's the formula. Let's go with that. I'm going to go ahead with the bingo, the dog. X final, I'm applying this guy for the bingo. X final, that's what I'm looking for, equals x initial plus v initial time plus 1/2 acceleration time squared. Now, changing the color, initial position 0, Okay, there we go. 0. Starting from rest, initial velocity 0. 0 multiplied by time. It doesn't matter for us. Right here we get x final for the bingo equals 1/2. The acceleration was 1 and time squared. Let's do the same. We are trying this formula for the Manu. X final for the Manu, x initial plus v initial time plus 1/2 acceleration time squared. And again, everyone, right here, x naught or x initial, the notations are the same. They are referring to the same one. V naught or the v initial, they refer to the same initial velocity. For the final position for Manu, x initial, Manu is starting at 30 meters. Okay, 30 meters. Plus, this guy is moving with a constant velocity, acceleration 0. We can put this guy to a 0. 2 is the velocity, and it was a negative velocity because it is going in the negative x direction. We said this is the positive x direction for our problem. And the time. Okay, now here is the condition. Final positions, they should be the same. We can set them equal. We have it, everyone, right here. 1/2 t squared plus, sorry, this one should be equal of, hello everyone. Okay, we have 1/2 t squared equals the other side 30 minus 2 times the t. If we bring everything to one side, we have a quadratic formula, 1/2 t squared plus this guy comes to the left hand side, 2 times t minus 30 equals 0. Everyone, this is the same as what I have right here. When you have this formula, 2 times the t, 0.5, 2 times t minus, and you have the quadratic formula, you set it up to find the roots. T equals, you get 2 answers. One of them is a negative number that cannot be the answer. We have the possible only positive answer out of the 2. 6 seconds, it means it takes 6 seconds for the bingo to go and find or meet the Manu. It takes t equals 6 seconds. Now it is really easy. Answering the part B and answering part C. How far the home when they are going to meet? You can either consider Manu, either consider the bingo, or you could do both to check is the answer correct. So we are trying to find what is the final position. Let's consider bingo. X initial plus V initial time plus 1/2 acceleration time squared. X initial for the bingo is a 0. V initial for the bingo is a 0. We have 1/2 times 1 is the acceleration for the bingo, the dog, time 6 squared. We have 1/2 times 36, which is equal to 18 meters. That is the final location when they meet. In our diagram, this guy becomes 18 meters when they meet each other somewhere here. Okay, not the exact, the middle 15, a little towards the, a little 3 meters towards, from the middle towards Manu. Okay, because this guy is accelerating while Manu is with a constant speed. And how fast the bingo is running when they meet? Okay, very easy. We could do many things. One of the possibilities is V final equals V initial plus acceleration time. For the bingo, acceleration of the bingo, we have the initial velocity of the bingo 0. Okay, the final of the bingo equals 0 plus acceleration 1 times 6 meters per second. That's one possibility. And also, since we know how much is the displacement for the bingo, that is 18 meters, if someone need, you could use this formula as well and take the square root. Okay, 2 times 1 delta x is 18. Take the square root. You will find a similar answer. Okay, so everyone, I'm talking about for the part C, V final squared for the bingo equals V initial bingo squared plus 2 times acceleration delta x. We have it is 0 the initial, we have it 2 times acceleration of the bingo. Bingo is displaced from the origin 0, 18 meters. We found it earlier here. Now we have 1 times 18. This is equal to 36. We have to get the square root. The final of the bingo, we have to get the square root of the 36. That is equal to 6 meters per second. They are the same answer, no matter what method you take. Okay, so always look for this guy. Method 1, this is the method or the approach number 2. Always look for alternate approaches, really good to have. Okay, see you guys.